Okay, so in the last session, we started with linked list. There we have seen the basic understanding of list. Then we have seen the differences between list and array. Then we started with the implementation of node. That what do you mean by node? How to implement a node practically in C, and then how to interconnect the multiple nodes. So for that, we started with this code, and here we can see that we implemented the node in the form of a structure, a self-referential structure, basically. So a structure which has a pointer to itself. Then we started with some small code of creating a node with the help of a malloc library function, and then we entered a data or inserted a data into that node. We set the next pointer of the node to null, and then we simply made the head pointer of the list to point to that node. So this is something like a only node in the list. So this is just to understand it at a very basic level. Otherwise, the way we discussed in the last session that we shall be implementing different functions to perform different operations on the linked list. So we'll be making up a modular kind of program where you will be having one function to insert the node, then one function to delete the node, then one function to display the content of the list, and so on. And in linked list, when we talk about the different operations on linked list, so basically what happens that a single insertion operation can be with the different possibilities. Okay, what I mean to say that you can have one version of insert function which can insert a node at the end of a given list. Then there can be another version which can insert the node at the beginning of the given list. Then there can be another version which can insert a node uh, after a given node. Likewise, inserting a node before a given node. So different possibilities are there for the different operations on list. So when you talk about inserting a node, so that insertion can be done at the end of a list, insertion can be done at the beginning of a list, insertion can be done after a given node, insertion can be done before a given node. Okay, so there are different possibilities. By default, it is insertion at end or insert at end. So by default, when it is asked to insert a node into a linked list, so by default it is insert at end. Okay. Likewise, when you say delete, so you can delete the last node, which is by default. So deleting a last node of a list, then deleting a first node of a list, then deleting a given node of a list, then deleting a node after a given node, deleting a node before a given node. So there are different possibilities when you talk about a delete function. So there can be a delete function which will delete only the last node, then a delete function which can delete only the first node, and likewise. And here also the default is deleting the last node of a given list. I repeat, the default function when you say delete a node, it simply means deleting a last node of a given linked list. Fine. Then you have displaying the content of the list. So in this case, you will be starting from the first node using a head pointer. Then you will display the content of the first node. Then you will move to the next node using the next pointer of the first node. Then you will display the content of the second node. Then you will move to the third node, display the content of the third node, and so on till you reach the last node. The moment you reach the last node, display its content, and when you try to move beyond the last node, so the next pointer of the last node would be pointing to null. So there you can stop. So the moment the next pointer of a node is null, you can stop. Okay. So that is your display function. Then likewise, you can perform the operation of say joining two lists together, and you can perform the operation of reversing a given list. Okay, so a list has been given to you and you need to reverse a given list. Then as I said, you can join the two given lists. or you can copy one list into another list. So there are different possible operations on a given linked list, but we'll be starting with the basic operations like inserting a node with different possibilities, then deleting a node, then searching for a given node, then displaying a list. Okay, so these are the basic functions which we'll be implementing for the basic operations of list. Once these functions are done, then you can easily implement the functions like reversing a list, then joining the two lists, copying a list, so on. So let's start with that. Now, when we say that we are making a modular program by implementing function for each and every operation which we want to perform on a data structure, so we also say that we try to make it more and more generalized program. So in the sense that whatever data is required to be sent to the function will be sending that data. Then whatever the function is supposed to return, the function would be returning. Okay. So we'll be doing a proper message passing between the functions. So that our functions can be kept as general as possible. Okay. Now, in the main function, what we can see that here you have the head pointer. So this head pointer is basically heading a list. So if I am having one list in my program, so I can have one head pointer. If I'm handling two lists, I can have two head pointer. If I'm handling three lists, then three head pointer, and so on. So if you just try to compare this with the implementation of stack and queue, so you can recollect that in the main function of stack and queue, what we used to have a variable of structure stack and a variable of structure queue. So if you wanted to have one stack, so you could declare one variable to structure stack. If you wanted to have two stack, then you could declare two variable to structure stack. Likewise for queue. In the same line, when we are handling a linked list, so what we are doing in the main function or in whichever function we need a list, there we can declare one pointer. There we can declare one pointer to structure node or the list structure. You can say list or the structure, whichever is there to make up a node of a list. Okay, so here we have named that structure as node. This structure can be named as SLL. This structure can be named as CLL for circular linked list. This structure can be named as DLL for doubly linked list. So it's all up to us. We can name it as per our requirement. So now we have named it as node, and generally what I do that depending upon the different type of list, I just change the name of this structure. Even if you do not change, syntactically it doesn't make any difference, but only logically to understand that this node is basically for singly linked list. So I simply name it SLL for singly linked list. Likewise for CLL, I name it for circular linked list, I name it as CLL. And for doubly linked list, I name it as DLL. So it's entirely up to us that what name we need to give. The only point we need to remember that the name should be valid and it should be logical. Okay. So valid means it should be conforming to the syntax of the programming language, and logical means it should reflect its use, why it is there, or what is the use of that identifier. Okay. So when we have a function, what I was saying you that we need a head pointer inside, for example, the main function. So this head pointer initially we'll be setting it to null, specifying that there is no element into this list or the list is empty. So if my head pointer of a list points to null, it simply means that my list is empty. Okay. Now I want to insert a node, and as I said you by default, it is insert at end. So I am implementing a function insert at end. Okay. So I can safely call it insert at end. It's valid and it's logical. The name is valid and logical. Insert at end. Now when I make up that function insert at end, let me write it here. I am calling it insert at end, for example. Okay. So what all things I need to pass? Can you tell me what all things I need to pass to this function? I'm implementing a function to insert a given node or a given data at the end of a given list. I repeat, function to insert a node or a given data at the end of given list. Okay, please answer into the chat box. What should be the arguments to this function? Yes, come on. Node and data. Okay. Structure data to be inserted. What else? I'm getting few answers. Daniel says node and data. Then Farhan says structure and data to be inserted. Alfia says node and pointer. Okay, what else? Always try to start the thing conceptually and then try to convert it into practical aspect. Okay, what I mean to say that what we are saying, insert at end. Insert a given node at the end of given list. The word given is important. So insert a given node or given data at the end of given list. Okay. So data is going to be given to us and a list is going to be given to us. So two things we are going to get, or what I mean to say, this function is going to get two things, given data and given list. Okay. So now the data which we are going to insert into this node would be of type integer. Why? Because inside this structure node, we are storing a data of type integer. So the data which we are passing to this function is expected to be of type integer. Then the list. How you will be passing a list to this function? Obviously, when we are passing from the main function, so we'll be passing what? The head pointer of a list. Okay. If I am passing head, so it is a pointer to one list. Likewise, I can have head 1, pointer to another list, head 2, pointer to another list, and so on. Okay. So basically, what I am going to pass to my insert at end function, the head pointer. That head pointer is specifying my list. Fine. Now, this head pointer is what? It is a pointer to structure node. So what I need to have here, the first argument is a pointer to structure node. I repeat, the first argument is pointer to structure node. So star H, let me call it. Go ahead. And the second argument is a data. So let me call it D. Okay. So we got two arguments to this function, a pointer to structure node and a data of type integer. Okay. Now, since we are working in singly linked list, so let me rename it as SLL. That's better. This may avoid a lot of confusion in the later part of the program. So let me call all this node as my singly linked list. So now it makes a sense that I am having a pointer to my singly linked list, SLL. Okay. So now we have renamed our structure and we are calling it as SLL for single linked list. And so the pointer also becomes pointer to struct SLL. And likewise here we pass a pointer to struct SLL and then we pass a integer data. Okay. What we'll be doing over here, we need to create a node and insert a node at the end of a list. Okay. So for that, what I will be having, uh, let's have some pointer. Let me call it as P. Then let me have one more temporary pointer. Let me call it as TMP for temporary pointer. And nothing else I need. So now the first thing I need to do is a request for the space or request for the memory. Okay. And that is done with the help of which function? Malloc function. So I will be calling my malloc function and I need a space which is equal to or which is equivalent to size of my structure SLL. Okay. And then this will return me a pointer to void which I need to typecast to struct SLL star pointer to struct SLL. And this I will be taking into my pointer P. I'm writing P equals to. Let me change this also. So now we are requesting for the space in this statement. In this statement, we are requesting for space and we shall be checking if P equals null, then I have to say printf, since the return value from malloc is null, so we can easily say not enough space or we can proceed, we cannot proceed, not enough space or not enough memory. And then we need to return. Okay. What I have to return that I will tell you soon. So let me simply write it to return. And then we come into the next part, that is if P is not null. So no need to write else because inside if we are returning. So here, thank you, semicolon. So here we come when we do not go into the if part. So this is if P not equals null. Okay. So when P is not equal to null, it means that a space has been allocated. So I can safely say now P of data. Now I'm assigning my data P of data equals to D. So this given number or this given data which is into D, that we are putting into P of data, and then we are setting the next pointer of this P as null. Okay, fine, absolutely fine, done. So now a node has been created. What we can see that a node has been created. Okay. Now what we need to do, we need to see that for the given data, a node has been created, and now we need to attach this node. And where we need to attach this node? At the end of a list. But before doing that, we need to check whether there is something in my list or not, in the given list or not. If there is nothing in the given list, so this node is going to be the first node. I repeat, if there is nothing in the given list, then this node is going to be the first node. If there is something in the given list, then we need to go to the last node and we need to attach this new node at the end of a given list. Okay. So I need to check whether there is something in the list or not. And for that, what we need to do, a head pointer of the list has been sent, has been passed to this function. Okay. And that head pointer is coming in this H. The head pointer is coming into the pointer H. So here I need to check, yeah, if there is nothing in this pointer, it means that my list is empty right now. Okay. How to check if there is nothing? Simply by saying if H, this pointer, equals null. If my H double equals null, it means that there is nothing in the list. And when there is nothing in the list, so I would be saying that this node is the first node. This node, which is pointed by P, is the first node. So my head should start pointing to this node. I repeat, my head should start pointing to this node because this node is the first node. Okay. So head means H equals to P, simply. H equals to P. Else, if this is not the case, if H is not null, so now here we need to code. What do we need to code? We need to go to the end of a list, and then when we reach the last node, we need to attach this node to the last node. How we'll be doing that? We'll be doing that by traversing into the list. I repeat, we'll be doing that by traversing into the list. Okay, we'll be traversing in the list, and then we'll go to the last node, and then at the last node we'll attach this node. Traversing a list is nothing but starting from the first node and then visiting each and every node by checking whether this node is a last node or not. Okay. How we'll be doing that practically? Starting from the first node. First node is pointed by the pointer H. First node is pointed by the pointer H in this case. So let me make use of the temporary pointer TMP equals to H. The moment I write TMP equals to H, so the pointer TMP also starts pointing to the first node. TMP also starts pointing to the first node. Okay. So TMP equals to H, H is pointing to the first node. So when we write TMP equals to H, TMP also starts pointing to the first node. Then I write while TMP of next not equals to null. Say it carefully. While TMP of next not equals to null. Now TMP equals to H, so TMP is pointing to the first node. When I write TMP of data, so I get the data of the first node. When I write TMP of next, so I get the next pointer of the first node. Okay. So what is the condition while TMP of next not equals to null? Now this condition would be true if TMP is pointing to the last node. Why? Because the next pointer of the last node is null. In a single linked list, the next pointer of the last node would be always null. Okay. So when we say that the condition is while TMP of next not equals to null, it means that we are trying to go to the last node. Okay. Till we do not reach the last node, keep on executing this loop. Till we do not reach the last node, keep on executing this loop. So what we'll be doing into this loop? Okay. What we need to do? We need to move to the next node. What we need to do? We need to move to the next node. Then again we'll go up. We'll check whether this node is the last node. If not, then move to the next node. Then we'll check whether this node is not a last node. If not, then move to the next node. Okay. So we'll keep moving to the next node till we do not reach the last node. And for that, I need to write this same pointer TMP. I need to make this TMP to point to the next node. I repeat, inside this while loop, I need to make this TMP point to the next node. Okay. Now this statement may look little tricky. This statement may look little tricky, but it is not at all tricky. Okay. It only looks tricky. Once you understand this statement, so it is quite straightforward and simple. What I am writing, TMP equals to TMP of next. Done. I repeat, TMP equals to TMP of next. Okay. Read this statement carefully. See the statement carefully. We are saying TMP equals to TMP of next. So if TMP is pointing to the first node, and suppose I got two nodes in my list, TMP is pointing to the first node initially. So TMP of next is not null because TMP of next is pointing to the second node. Okay. So the condition is true. TMP is not null. So we'll go inside the while loop and then we'll say TMP equals to TMP of next. TMP is pointing to this node. TMP of next, this pointer is pointing to second node. So when you write TMP equals to TMP of next, so the TMP pointer starts pointing to the second node. I repeat, the TMP pointer which was pointing to the first node now starts pointing to the second node. Okay. And this way we'll keep on moving next. This way we'll keep on moving next till we reach the last node. The moment we reach the last node, we'll come out of a while loop because the next point of the last node would be null. So the condition will fail that it is not null. So the moment we reach the last node, we'll come out of a while loop. And then when we come out of a while loop, TMP is pointing to the last node. I repeat, TMP is pointing to the last node. So here I can safely say that now TMP is pointing to the last node. So I would say TMP of next. That is, the next pointer of the last node should be now pointing to the new node. So that new node would come at the end of a list. So TMP of next equals to P. And the moment I write TMP of next equals to P, then the P would be attached to the earlier last node of the list. And now P becomes the last node. The node P becomes the last node. And then after this if else, I need to simply say return. And what I need to return? I need to return the H pointer. Okay. So here also I need to return the H pointer. So what we are returning the head pointer of a list. We are returning the head pointer of a list. And since this H is of type what? See here carefully. What is the type of H? H is pointer to structure SLL. As S is a pointer to structure SLL, and that's why since we are returning this H, so the return type of the function becomes pointer to structure SLL. The return type of the function becomes pointer to structure SLL. Okay, so this is my function. This is a function name, and this is the first argument. This is the second argument, and this is a function. Do not get confused for this. This may look like little tricky, the traversing part, but this is as good as writing. Here you are writing I equals to 0, and then in the while loop you are writing while I not equals to phi, and then inside the while loop you are writing I equals to I plus 1. This is as simple as that. Okay, so I equals to 0, then while I not equals to phi, then inside while loop you are writing I equals to I plus 1. So what we are doing inside the while loop, we are making I to have a next value to its previous value. The previous value was 0. Now I equals to I plus 1, so it will become 1. Again, check the condition. I not equals to phi. Yes, it is true. It is not equals to phi. It is 1. Get inside the while loop. Then I equals to I plus 1. So now it is moving to the next value of I. I's value is 1. So I equals to I plus 1. So I becomes 2. Okay. So this is as simple as that. Fine. Now, what we'll be doing that the same function I am putting into my presentation, and there we'll try to see that how the function works. I'll explain you, but now what we'll be doing, we'll be seeing with the help of presentation that how the thing moves and how the work is done. So let me try that by again presenting, because I was presenting a window. I need to stop that. And let me present my entire screen. Okay, so here's a presentation, data structure, linked list, and this is the code. This is a function which we have seen. Okay, so I request you to see the function properly, and what we are doing, it is same. It is same function what we have implemented just now. And I'm requesting that if you are not able to see or read it properly, for example, if the size of the font seems to be a little smaller to you, you can just expand it. You can pinch it out. So if you just pinch out your display, your screen, so you would be able to enlarge the presentation and you can easily read it and see it. Okay, so it is the same function which we have just implemented. So the return type of the function is pointer to structure SLL, then function is insert at end, then you are passing two arguments, then inside it you have some dummy pointer declaration, then the malloc function, then checking for the return value of the malloc function. If it is null, then not enough space to allocate, then return the pointer h. Then the next is setting the data part. Okay, so let's see how it is done inside the memory. So here I can see that now this is what you can see in front of you is basically a outcome of P equals to struct SLL star malloc. So let me make use of a pen. What I mean to say, this statement is because of this malloc. So whatever is happening here, this is happening because of the malloc statement. So now we are assuming that a memory has been allocated and the pointer P, this pointer P now has started pointing to a node, and the node is having two parts, a data part and a next pointer part. Okay. Then next, what happens next that since uh, memory has been allocated, so we move to this part, and here for this two statement, this two statement, uh, this will be doing. So P of data equals to D. This is happening over here. So into the data part we have D, and then the next statement is P of next equals to null. So into the next part we have null. Okay. Now once this is done, so our node is now ready. We have created a node, and into the data part we have inserted the given data, and into the next part we have set it as null. Okay, so our node is now completely ready, which is pointed by P. Now the next statement over here is checking whether the given list is empty or not. Okay, this statement, so checking whether H is null or not. So if H is null, in this case, when H is null, so see carefully what we are doing. When H is null, so we are understanding that this node is going to be my first node, and that's why I need to set H to P. That's why what we need to do, we need to set H to P. So the moment you set H to P, what's happening that our pointer H, the first pointer, the head pointer, sorry, the head pointer H is going to point to this node. Okay. So now the head pointer has started pointing to the node. Which node? Just now created node, which was pointed by P. Okay. So if my given list is empty, if H is null, so my head pointer will start pointing to this node. Else, if this is not the case, it means that there are some nodes into my list. Already there are some nodes into my list. So let's take an example for that. that in this case, in the else part, the head pointer which is passed to this function and which we have received into the pointer h, this shall be pointing to a list. And suppose this is a list. Okay, I request you to please move into your display part and check the node. It has got two nodes. The first node is having a value 10. Then the next part of the first node is pointing to the second node, and second node is having a value 20. And then the next part of the second node is null, because the second node is the last node into this list. So now H is pointing to the first node of a list, and this list has got two nodes. Okay, so we are coming into the else part, and this is the scenario, this is the example. And now we need to what we need to do, we need to attach a new node, which is our P. We need to attach this P, our new node, at the end of this node or at the end of this list. Okay, so we are coming into the else part, and this else part is now important to us, very important to us. If we understand this else part, so we are understanding a lot about linked list. What we are doing into the else part, in the else part, we are traversing. We are traversing. We are making use of one additional pointer called TMP, and then we are making TMP to point to H. So we are writing TMP equals to H, the first statement in the else part. So the moment you write TMP equals to H, H is pointing to the first node, which is having a value 10. So TMP also starts pointing to the first node, that is 10. Okay? Then we'll go to the while statement, while loop. The statement or the condition is TMP of next not equals to null. TMP is pointing to this node 10. Okay? TMP of next is this. Whether this is null? No, it is not null. It is pointing to another node. So this is not null. So this condition, TMP not equals to null, this condition is true. This condition is true. So when the condition is true, we'll come inside the while loop. And since there is no opening and closing curly braces inside the while loop, so there is only one statement inside the while loop. That is TMP equals to TMP of next. Now the moment you write TMP equals to TMP of next, what happens? That see here carefully, please. TMP is pointing to the node having a value 10. TMP of next means this value. Okay. And this is pointing to a node 20. So the moment I write TMP equals to TMP of next, so this is my TMP of next, which is pointing to 20. So the address of this node, address of the second node would move into TMP. When you write TMP equals to TMP of next, so basically we are making the address of the second node, address of this node to move into TMP. Okay. And what will happen when we write TMP of next? Immediately my pointer TMP starts pointing to the next node. So it is now shifting and it is now starting pointing to 20. I repeat, earlier it was pointing to the first node. The moment I write TMP equals to TMP of next, now the same pointer starts pointing to the next node. Okay. So this is how what happens when you write TMP equals to TMP of next. To whichever node TMP was earlier pointing to, the moment I write TMP equals to TMP of next, it would start pointing to the next node. Okay. So now TMP starts pointing to the next node. Again, we'll go to the while loop. We'll check for the condition temp of next not equals to null. Now, in this case, temp is pointing to a node having a value 20. And if you see what is temp of next, so this is my temp of next. And what is temp of next now? Null. So now this condition temp of next not equals to null, this condition is false. The moment this condition is false, we go out of a while loop. And when we go out of a while loop, so we are reaching to this statement. this statement. And what is this statement? TMP of next equals to P. Okay. TMP is this node, the last node of my list, this one, and TMP of next is now null. So what I'm doing now, TMP of next equals to P. The moment I write TMP of next equals to P, so this node, which is P, having a value D and null, okay, this node will come into picture. This null is getting removed from TMP of next, and it will start pointing to this node. It will start pointing to this node. And the moment it starts pointing to this node, the new node gets attached to our existing list. Okay, and it becomes a part of our existing list, or it becomes a last node of our list. Okay, then we come out of this else loop, else block, and then the last statement is return h. So we are returning this pointer, h pointer. Okay, here also in f, if h is null, we are setting h to the new node, and at the end the same statement return h would be executed for that also. So in any case we are returning the value of h. Okay, so this is how your node would be inserted at the end of a given list. Fine. So I hope you are very clearly understanding from this presentation, and I will be providing you this presentation so you can go through it and you can understand. And I repeat that what is the most important to understand is this part, TMP equals to TMP of next. If you clearly understand this, it's simple. It only looks little tricky. What is that? TMP equals to then TMP, then arrow operator, then next. It looks little tricky. That's all, nothing else into it. It is as good as I equals to I plus 1. It is as good as I equals to I plus 1. Okay. So TMP is pointing to one node. The moment you write TMP equals to TMP of next, it simply starts pointing to the next node. That's all, nothing else. Okay. So that is called basically a traversing, and most of the operation, in almost all the operations, we make use of this traversing. So if this traversing is clear to you, you can easily perform different operations on list. Okay. So we stop our presentation here, and I hope all these things must be clear to you. And if there are some queries, so you can post the queries into the chat box. I'm stopping the recording now. Recording is getting stored into Mapari Simran's